coming to this lateral shift, what is that? The perpendicular distance from the emergent ray and the direction of the incident ray is called as the lateral shift, right? So you can see that the perpendicular distance is nothing but RT. Okay, so RT is nothing but it is the amount of the incident ray has been shifted. Okay, by what amount the incident ray has been shifted from its initial direction. Okay, so that perpendicular distance itself is called as the lateral shift, right? So for a normal incidence where I is equal to 0, as you know that even R will be nothing but equal to 0, so that the lateral shift will also be equal to 0. Suppose if the angle of incidence is equal to 90 degree, in that case the shift, okay, lateral shift will be nothing but equal to the thickness of the glass. Okay, thickness of the glass slab, it will be equal to the thickness of the glass slab. Okay, I think till here we discussed in the last class, I think, right? So coming to the next topic, that is nothing but normal shift. Okay, coming to this normal shift, so I'll just read out the explanation theory part. Let a point illuminated object at O placed in one medium be viewed normally from another medium as shown in the figure. So in the figure you can see that the object is placed in one medium and we are viewing that, we are seeing that object from the another medium. Okay, next, a narrow divergent beam of light from the object after refraction appears to come from I. Thus I is the virtual image of object. This means the object at O appears to be at I. This phenomenon is called normal shift. Okay, so see here, as you know that in the first figure, okay, in the first figure is nothing but what we are doing is we are placing an object in the denser medium and we are seeing that object from the rarer medium. So what is the difference we are going to see? Okay, so as you know that the ray which is coming from the object from the denser medium, okay, so as you know that if this is the object, okay, if this is the object, so what happens here is the ray which is coming from the object, okay, so as soon as it comes here, so as you know that when you draw a normal here, okay, when you draw a normal here, as you know that when a ray which is coming from denser medium to rarer medium, it should bend away from the normal, right? So it bends away from the normal here. Okay, it's not able to draw properly, so understand the concept. Okay, so it bends away from the normal. Okay, similarly I'll take another ray, okay, which is coming from the object itself. So again if you draw a normal, so what happens, it should bend away from the normal. So when you extrapolate this, okay, when you extrapolate this, what happens, it meets at some point, okay, that is at this point. So hence for us who are seeing this object from the rarer medium, appears like the object is placed at this point. Okay, actually the object is placed at O, but for us it will be like, it will be assumed like the object is placed at I. Okay, so this is called as the normal shift we call. Okay, this is called as the normal shift. Okay, the best example is nothing but when you go to a river. Okay, when you see the uh, objects which is inside the river, okay, which is on the ground. Okay, so when you see that, it appears like it is very closer to you. Okay, but uh, when you try to lift that object, okay, when you try to get that object, so what happens, you will come to know the depth. Okay, the depth will be more. Okay, for us it will appears like the object is placed at very closer, like that it's going to appear for us. Okay, so that is called as normal shift. Okay, even the another example is nothing but you can take when you go to the river, there will be fishes, right? Okay, so when you see that small fishes, okay, so it appears like it is very closer to you, but when you try to catch it, so you'll come to know it is not very closer, it is little bit in a depth. Okay, that itself is called as the normal shift. Okay, so next, coming to the second figure here, it is exactly opposite to that what we have studied in the first case here. Okay, so we are placing an object in the rarer medium, and we are seeing that object from the denser medium. Okay, so what happens, the same phenomenon here. So when you see that object, okay, which is placed in the rarer medium, okay, so it appears like, okay, the person who is seeing that object in the denser medium, okay, which is placed at the rarer medium, appears like the object is very far for him. Okay, even though the object is placed very closer, okay, for the person who is seeing in the denser medium, appears like the object is placed at the far. Okay, so this is what we call this one as the normal shift. Okay, so one second, I'll just conclude it. Okay, when you place the object in the denser medium, and when you see that object from the rarer medium, the object appears to be very closer. Okay, but it will be far, but for us it will appear like it is very closer to us. Okay, similarly, when the object which is placed in the rarer medium and one who is seeing from the denser medium appears like, even though object is very close to, even though object is placed very close to him, it appears like it is placed very far from him. Okay, so this is called as the shift. Okay, in the position is called as the normal shift we call. Okay, so next is nothing but the relation between real depth and the apparent depth. Okay, so let us see what is this definition of this normal shift. The apparent shift in the position of the object along the normal is called the normal shift. Okay, so the apparent shift is nothing but what where we are going to see that, okay, for the person who is seeing from the rarer medium, where the object which is placed in the denser medium appears like the object is placed very closer, right? So you can see in this figure here, the object is placed at O, but for us it appears like it is placed at I here. Okay, and this shift is called as apparent shift, or we call that one as apparent depth. Okay, but the object is placed here, and this is called as real depth. Okay, so this is the difference between apparent depth and real depth. Okay, so next, there is a relation between the apparent depth and the real depth. Let us go through what is that. Before that, we will just focus on this figure. Okay, so AB is a surface which separates the denser medium and rarer medium, and you can see there Mn. Okay, Mn is the normal and O is the object placed, and you can see from O the ray is coming, okay, is coming out from denser medium to rarer medium. As you know that since the ray is moving from denser medium to rarer medium, it bends away from the normal. Okay, so and this angle we call that one as I, and this angle is called as R. Okay, so next, as you know that when you view that from the rarer medium, with the object which is placed at denser medium, it appears to be closed, it appears to be placed close, right? So because when you extrapolate this in the backward direction, it appears like the object is placed at I. Okay, so as you know that this distance is called as apparent depth, and this distance is called as the real depth. So now we will just focus on this. O is nothing but point object placed in the medium of refractive index N. AB, a refracting surface, and OP is nothing but a ray of light incident normally to the surface which proceeds undeviated along PQ. Next, OR, another ray of light incident very close to P, refracted along RS away from the normal. Okay, So next, I is the angle of incidence, R is the angle of refraction. The ray RS when produced backward meets the ray OPQ at I. Thus the refracted rays on reaching the eye appears to come from I. Okay. So I is the virtual image of O. OP is nothing but T, that is the real depth of the object. And next OI is nothing but the normal shift. Okay. So OI is nothing but the normal shift. You can see here the object is placed here, but it appears to be at this point. So this distance is called as normal shift we call. So next, the relation between the refractive index. As you know that the refractive index can be written as n is equal to u by v, where u is nothing but real depth and v is nothing but apparent depth. So if you take out the apparent depth on the left hand side, so that can be written as real depth by n. Okay. So and the normal shift definition can be written as S subscript n is equal to T into 1 minus 1 by n. Okay, which is not there in your syllabus to derive it. Okay, so directly taken, so just by heart it. Okay, S subscript n is equal to T into 1 minus 1 by n. So and the normal shift depends on the depth of the object, the refractive index of the medium in which the object is placed, next the refractive index of the surrounding medium. Okay, so this is regarding the normal shift, apparent depth and real depth. Okay, so just go through this normal shift and this relation between apparent depth, real depth and refractive index. So in case if you have any doubts, please let me know. Okay, just go through for a few minutes. So in especially the ray optics, always first go through the figure, understand the figure, and then in your own words you can write yourself, you can derive in your own words. Okay, first understand the figure. Okay, students, any doubts? In case if you have any doubts, you can let me. Okay, so next is nothing but the two, uh, that is refraction through atmosphere and the twinkling of stars. I think this thing you have been studied in your lower class itself, right? So anyhow, we will just go through. Sun becomes visible before the actual sunrise and actual sunset due to atmospheric refraction, as shown in the figure. Let S be the position of the sun below the horizon during sunrise. When the rays from the sun at position S enters the Earth's atmosphere, then they meet a medium of increasing density. They continuously bend slightly towards the normal. So to an observer on the earth, the sun, which is actually in the position S below the horizon, appears in the position S dash. Okay. So thus the sun appears of rise early by 2 minutes before the actual rise. For the same reason, it appears to set late by 2 minutes after it actually set. Therefore, the day becomes longer by about 4 minutes due to atmospheric refraction. The oval shape of the sun at sunrise and sunset is also due to refraction. Okay. So as you know that when you compare the day and night, the day comes out to be little bit 4 minutes longer compared to night. Okay. Why is that? It is due to the atmospheric refraction. So as you know that the sun, when you take the sun, okay, sun rays which is entering the earth's atmosphere, okay, so uh, when the sun rays reaches us, okay, by passing through the different layers of atmosphere, so what happens, the density, so the density keeps on increases, okay, the sun rays which is coming to the earth, which is reaching, when it reaches us, okay, so the sun rays travel in different layers of atmosphere of increasing density, okay, hence what happens, they bend slightly towards the normal. So if you consider this as the actual position of the sun, so for us who is standing on the surface of the earth, okay, the person or the observer who is observing above the surface of earth, for him the sun rays appears to be coming from here, that is above the horizon. Okay, this is the horizon. So for us, even though the sun is below the horizon, for the person who is observing from the surface of earth, appears like the rays are coming from the above the horizon, hence he concludes that the sun is at this position, okay, but the actual position of the sun is below the horizon. So hence, for the same reason, what happens here is, even during the sunset, what happens, even though the sun has already set, for us it appears like the sun has not set actually, okay. So for this reason we say that the day is longer by 4 minutes compared to the night, okay. So this is due to the refraction of the refraction through the atmosphere, okay. So next is nothing but it is regarding the twinkling of stars, okay. So twinkling of stars is nothing but star shines in the night sky because they emit their own light. Twinkling of stars is due to atmospheric refraction of stars' light. The continuously changing atmosphere reflects different amounts of light at different moments. Therefore, the amount of light refracted by it also varies. Because of the variation in the intensity of stars' light reaching us, the stars appear to twinkle at night. So, as you know that the twinkling of star is also due to the atmospheric refraction, okay. So since the light, okay, the star's light which is entering, which is passing through the atmosphere, so due to what happens, due to change in the density of the atmosphere. Okay, different layers of atmosphere. Since the light passes through the different layers of atmosphere, what happens, there will be continuously change in intensity of light. Okay, of the star's light. So hence when it reaches us, okay, it appears like it is twinkling. Okay, but actually the star doesn't twinkle. Okay, it is due to the light, star's light, which is passing through the atmosphere. It is due to atmospheric refraction, it appears to be like twinkling. Okay, so this is regarding the refraction through the atmosphere, that is actual sunset and sunrise and twinkling of stars. Okay, so just go through. In case if you have any doubts, you can ask. Yes, any doubts regarding these consequences due to refraction? So you have lateral shift, normal shift, refraction through the atmosphere, twinkling of stars. In case if I have any doubts, you can ask. Okay, fine. Okay, so next is nothing but total internal reflection. Okay, so before that, coming to the test. Okay, as you know that it is on 21st, 22nd and 23rd, right? I think. Okay, so as I have forwarded some of the important questions, okay, in the group, you can just go through that questions. Okay, but don't expect, okay, don't expect the question from that important question what I have sent. Okay, so some of the questions you may get from that. Okay, because whatever the question I have sent, it is from the final examination point of view. Okay, so if you just go through the final year examination papers and the question which I have sent to you in the group, you can just check most of the questions. Okay, it has been taken from the final examination itself. The same question has been asked in the final examination. Okay, so hence it is very very important. Okay, so those who want to score good marks, just go through the whole chapter. Okay, all that is the entire chapter of electric field and charges, electric potential and capacitance, atoms, nuclear, complete chapter, please go through. Okay, in case if you want to score a good marks. Okay, so as I said, so some of the questions you may get from the questions, I mean in the test, some of the question in the test you may get from the questions which I have sent in the group. Okay, but not all the questions. Okay, so Yeah, Nikhil, how is test is going to conduct, sir? See, coming to the conduction of test. Okay. So as I said, you need to write. It is a written test. Okay. It is not a MCQ based. It is a written test. So be ready with a A4 size sheet paper. Okay, with a pen and a calculator. Okay. So we are just going to share the question paper either through Zoom meeting or it may be through a WhatsApp group. Okay, we will confirm you by today. Okay, by today evening, you'll come to know what is the actual procedure. Okay, so we are going to share the question paper. So once you get the question paper, you need to start. Okay, so within 1.5 hour, you need to complete. Okay, you need to write in the A4 size sheet itself neatly. Okay, so everything should be the work done and all. It should be done in the sheet itself. Okay, so once you complete the test, what you need to do is you need to scan it and you need to convert that into PDF form. Okay, scan your papers. Okay, all your papers. I mean, in case if you are written in 4 or 5 sheets, you need to scan all that 5 sheets. Okay, so scan that, convert that into PDF form, and you need to send to us. Okay, so this is the actual procedure. Okay, so we will confirm you once again the conduction of test by today evening. Okay, I think you may get the official procedure, okay, of the test in your group by today evening, I think. Okay, so be ready, and it's for 50 marks, right? So be ready, and this is regarding the uh, procedure of test. And coming to the numerical, uh, I'll just let you how the paper is set. Physics paper is set. Okay, I don't know about other paper. I'll just tell you how the paper is set. See, you will be having, as you know that there will be a 1 mark. First main will be of a 1 mark. So 1 mark, no choice. You need to answer all. Coming to the second part. Okay. So it is 2 mark question. Okay. You will be having 5 questions, I think. Okay. You will be having 6 questions. Out of 6, you need to answer 5. Okay. So next, coming to the 3 mark questions. Again, there will be a 6 questions. Out of that 6, you need to answer any 5. Okay. So next, coming to 5 marks question. Okay, 5 marks question. There will be a 3 questions. You need to write any 2. Okay. So after that, you will be having a numerical. So coming to the numerical, no choice in numerical. You will be having the 2 numerical. You need to solve 2 also. Okay. No choice in numerical, because as you know that numerical is very important. You cannot expect the numerical of the same type, so that you can say you cannot judge the numerical type of numerical which can be asked in examination. Okay, so hence you need to go through all types of numerical. So just go through all the numericals which have come across in all the 4 chapters, so that it will be very easy for you to get ready for your final examination. Okay, so hence no choice in numericals. So 2 numericals will be there. You need to answer 2, and the marks for numerical is nothing but 5 marks, 5 marks each. Okay, any other doubts regarding the test? Okay, Nikhil, any notification on reducing syllabus, sir? See, no official notification from the PO board. Okay, don't don't go through the no messages which is coming in the WhatsApp group. Okay, so uh, it is not a official confirmation by the PU board. Okay, so no idea about the reduction of the syllabus. Yeah, you will be having option in 2 and 3 marks. Okay, so 6 questions will be there in both 2 and 3 marks questions. Second and third main. Second main will be of 2 marks, and the third main will be of 3 marks. So in both second and third main, you will be having 6 questions each. Okay, so out of 6, you need to write 5. Okay, so in 5 mark question, as I said, 5 marks derivations. So 3 will be asked, any 2 you need to answer. Coming to numerical, it is nothing but you will be having 2 questions, 2 numericals. You need to answer both. each will be of 5 marks. Should we switch on your webcam, sir? So Gokul, that is what I said. You will come to know the actual procedure by today evening. Okay, how the test is conducted. Okay, you'll get the official confirmation message from the group itself. You'll come to know. Okay, so as of now, this is the pattern of the question paper. Do you have any doubts? In case if you need any clarification regarding the test, you can ask. I mean the pattern of question paper or something related to the test. Anything else? Okay, fine. So just a minute, I'll take the attendance. See, as I said, don't just go through that WhatsApp messages. Okay. So even I'm getting that messages regarding that syllabus reduction. So don't trust that. Okay. So it is not an official confirmation from the PU board. Hence, you need to go through all the concepts which we have come across. Okay. So once there is an official confirmation from the PU board, I'll let you know about that. Okay, Harshita, it's fine. You can write in sheet itself, ruled A4 size sheet itself. Okay, ruled or unrolled, it doesn't matter. Okay, but you need to write the test in A4 size sheet itself. Okay, okay, fine. With this thing, I'll just conclude today's class. Okay, in the next class, we will start with total internal reflection. Okay, thank you, students.